We present AutoGPart, Intermediate Supervision Search for Generalizable 3D Part Segmentation. Learning the concept of parts is of great importance in real-world applications, like robot grasping, shape design, animation synthesis, etc. Shapes may be segmented into parts via different criteria, like geometry shapes, mobility, and semantic information. Most approaches to part segmentation only focus on in-domain generalization. However, generalizing to out-of-domain shapes is an ideal property considering new environments a vision system may encounter every day. Current generalizable approaches always present complex task-driven solutions designed based on heavy task-specific knowledge. Therefore, we aim at a generic strategy for generalizable segmentation networks to get rid of such sophisticated human designs. The main challenge here is shortcut features in the training shapes that would hinder the network from learning real segmentation cues. To tackle this problem, we propose to add intermediate supervisions for regularization as a unified solution. A simple but classical strategy for part segmentation is training a network using the task-related loss in a supervised manner. Our method then adds intermediate supervisions as an auxiliary loss. We propose a generic supervision space for part segmentation tasks, and a strategy to optimize the space so that useful supervision features for a specific segmentation network can be found automatically. We generate supervision features from tree-structured operation sequences, named operation trees. An operation tree is composed of feature operations at different levels and input per point features. An operation may be a unary operation, a group operation, a binary operation, or a null operation. Here, we show a feature generation example, whose output is the rotation matrix of a pair of input point clouds. We then model the distribution of operation trees to construct the supervision space. The distribution is factorized into a set of conditional distributions. The operation space is then optimized by looping 3 steps, that is supervision sampling, supervision evaluation, and supervision space update. In the first step, we sample a feature from the space. After that, the sampled feature is used to train the network. We take the cross-domain generalization performance of the optimized network as the reward value of the previous sampling step. The operation space would further be optimized by the reward value using the reinforce algorithm. Now we show some samples of searched intermediate supervision features. We can observe that such features are continuous in geometry, but also part discriminative. They can be treated as some intermediate forms lying between part segmentation and geometry. That may count as an intuitive reason why we can expect a network to learn generalizable segmentation cues from them. We can also observe similar feature patterns from shapes in the mobility-based segmentation task. Then we present some segmentation results of the method. For the primitive fitting task, our method can get better segmentation performance on out-of-domains shapes than the method designed specifically for the task. For the mobility-based part segmentation, adding intermediate supervisions can also improve the network's generalization ability by just training on categories like chairs, motorbikes, cars, planes, etc. Next are some quantitative evaluations. In the left figure, our strategy can get better performance on the OOD test set than other methods. From the right figure, we can observe an obvious improvement of the network using searched intermediate supervisions in Cluster 2, the OOD test cluster. To conclude, the main contribution of the method lies in those 3 aspects. We propose a generic strategy for segmentation tasks to automatically find intermediate supervisions for generalizability improvement. We design an optimizable space to depict the distribution of useful intermediate supervisions. We propose an automatic search algorithm to find proper supervisions from it. This work also suggests the possibility of automatically learning more method components. Thanks for watching.